Hello my friends and welcome again. This is the third video into which, my friends, we are going to answer question number 3 of Pearson Edexcel International GCSE, and the year is 2024, 17th of May, and of course the subject is chemistry. As you know, my friends, we are going to answer the English questions later. So my friends, let's start question number 3 here. In question number 3, my friends, the question is about... Now, my friends, let's start answering question number 3. The question here stipulates that question is about elements, mixtures, and compounds. I'm going to start with A. The box gives some methods used to separate mixtures. I'd like to revise them quickly. We have crystallization. Crystallization, my friends, is a physical procedure into which we separate a soluble salt from a solution. So we have a soluble salt and we need to separate it from its solution, its solvent, let's say. And we have filtration here. We have insoluble salt, to separate insoluble salt from a liquid, which is generally a solution. Number 3, we have a fractional distillation. In fractional distillation here, we separate a mixture of liquids depending on the difference between their boiling points. And we have the simple distillation, my friends. In the simple distillation here, we separate the liquid from the soluble salts or from the insoluble salts in the solution. So in here we target the liquid or the solvent. Here we target the insoluble salt. Here we target the soluble salt to separate it. In here we target one component in a mixture of liquids, which are of course soluble into one another. So the question, as we finished here, the revision: choose methods from the box to answer these questions. Question number 1: identify a method to remove sand, which is insoluble salt, from a liquid, from a mixture of sand and seawater. So of course seawater is liquid. So the best way is the filtration, because here we want to remove the sand. We want to isolate the sand. So we target the sand here. Identify a method to separate a mixture of liquids here, my friends, according to their differences in their boiling points. So the best way is fractional distillation, as we said before. I would like to remind you, my friends, not to confuse it with simple distillation, because in simple distillation here we have a solvent, for example water, and this water contains a lot of let's say soluble and insoluble components with it. So as we know, my friends, here we target the solvent or the liquid. In here we have a mixture of liquids. So let's continue. B, diagram. The diagram shows part of the structure of silicon dioxide. Silicon, here we have Si dioxide. We have 2 oxygen, as we say. So this is silicon dioxide. We have the oxygen atoms in a gray and the silicon atoms in a black. So the question is, explain why the silicon dioxide is a compound. As we said before, my friends, we have 2 types of chemical materials. We have elements and we have what? We have compounds. As we said before, my friends, we have two types of chemical materials. The first type is called the elements. And as we know before, my friends, an element is a group of atoms that is made up of one type of atoms, means all the atoms in the element are the same. We have examples for elements. We have oxygen, we have iron, we have copper, for example, or any other elements, while a compound is made up of two or more different elements. As you see here, my friends, we have the silicon oxide, which has the chemical formula SiO2, and it is made up of silicon and oxygen, which makes it a compound, not an element. So explain why silicon dioxide is a compound. So it's a compound because it is made up of two different elements, oxygen and silicon, which are chemically bonded. Please, my friends, do not waste these two words. Pay attention for them. Chemically bonded. Because if we have a container, for example, here, if we have a container of oxygen and hydrogen, and those chemical elements, and let's say a piece of iron, put them into one container and they are not chemically bonded, those are not a compound. Those are three separated elements into one container. They should be bounded like the silicon oxide so that we can say that they are a compound. Let's move to the next page, my friends. The question here, the molecular formula of the compound insulin is C257, H383, N65, O77, and S6. So determine the number of different elements inside insulin. Generally, my friends, the question is, how many elements do we have inside this chemical compound? As we know, my friends, we have to isolate the elements. We have the first element here, which is carbon. The second one, hydrogen. Third one, nitrogen. We have oxygen and sulfur. 1, 2, 3, 4, 5. So we have 5 different types of atoms. So this chemical compound is made up of 5 different elements, which are carbon, hydrogen, nitrogen, oxygen, and sulfur, as we have just said. So the other question is, determine the number of atoms in a molecule of insulin. The answer is easy. We all need to add the numbers to one another. Let's see, we have 57 plus 383 plus 65 plus 77 plus 6, and the final number here, my friends, as I see, is 588 atoms in one molecule only. Let's move to the next question. Next question, we have something called magnesium. Magnesium is an alloy, my friends. How do I know it's an alloy? I read the whole question. Magnesium is a mixture of magnesium and what? Magnesium and aluminum. So it is made up of two chemical materials. One of them at least is a metal, and this is exactly the definition of an alloy. So the diagram shows the sample of magnesium here. Those are the magnesium atoms in gray. We have 1, 2, 3. So, and we have aluminum in white. All of these are aluminum. So if we have one molecule is made up of how many atoms? Is made up of 18 atoms. 15 of them are aluminum and 3 of them are magnesium. So what is the question here, my friends? The question is, calculate the percentage of magnesium atoms in this sample. The question is very easy here, my friends. We know that one molecule is 18 atoms, 3 of them magnesium. So we say each 18 atoms, which is one molecule of magnesium, contains 3 atoms of magnesium. So if we have 100 atoms of magnesium, the percentage is X. So we have cross multiplication, 100 multiply 3 over 18, and the percentage is 16.67. I guess this is the end of this video, my friends. Let's make a new video for question number 4, and I hope that you like this way of cutting or dividing the questions onto videos, so that you don't get bored. You can, for example, take a video 5 or 10 minutes to answer one question, which is better than making one video with 2 hours answering the questions. Now, my friends, let's move to the next video.